So in this video, I'm going to share to you how you can create high strength concrete mix design using this latest template. And this template is referencing to two standards. The first one, of course, is the ACI PRC-211.1 of 2022, along with the ACI 211.4R of 2008. So before we start, let me just highlight to you the definition of high strength concrete, reference to ACI 211.4R. This is the guide for selecting proportion of high strength concrete using Portland cement and other cementitious material. So if we go for page 4 of this standard, here the definition of the high strength is specified compressive strength greater than 6,000 psi. So to be more specific, let me start with 6,500 psi as an example. Next, let's say the slump value is 190 mm or 7.5 inch, and this will be pumpable at the tolerance of plus or minus 40, meaning to say 150 mm is the lower value and 230 mm is the higher value for this slump. The nominal maximum size of aggregate, let me just select from this drop down list, let's say 19 mm or 3/4 inch, and normally our maximum temperature would be 32, and let's say this concrete will be used for column. For the entrapped air, since this is high strength, according to standard, we just need to have the entrapped air, and automatically this value will appear here according to the standard, so you don't have to worry about this. So moving on, next will be the calculation of target mean strength. As you know, this is automatically being calculated. So without standard deviation, the target is 7,850 psi. But if you have, let's say for example 700 psi, so the calculated target mean strength will be less, will be 7,481. Anyhow, for this example, let me just go back to without any standard deviation so that the value will be higher. And so here you notice the proposed value referencing from the standard also. The value here is less, so it became red as a notification for us. So you just have to select here and look for the next higher value, which will be 8,000 psi. So now it's covering the or exceeding the 7,800 psi. And here you can select also either 28 days for the age of test or 56 days. And you notice that the water cement ratio is changing according to the table of ACI 211.4R. And we can also check from the standard. Let me just show it to you. So if we go back to the standard and look for page 11, here you can see here the 3/4 inch nominal maximum size of aggregate, or the maximum size of coarse aggregate. In 8,000 psi, 28 days, it will be 0.4 with admixture or the high range water reducing admixture. We can double check that from here. Let's go to 28 days again, 0.4 water cement ratio. Here 0.4, meaning to say we are selecting the correct value as per the standard. And let's go back to check 56 days. This 0.42. So I'm just showing you that the template is very reliable and precise according to the recommendation of this guidebook. So this really saves your time. It will keep on suggesting you according to the standard, and you don't have to worry of going back to those pages. So my point here is that it will be much easier to create mix design using this advanced template. Anyhow, moving on, let's say the maximum water cement ratio is 0.45 in this example, and the minimum cement content is 400. So starting from the let's say higher value, for example, so we have to be less than or equal to this target value, which is 0.42. So let me just click this button to reduce the water cement ratio. We can use 0.42, or if you want to be at safe side, you can also use lower value in case you are new to the batching plant, for example, or the material is new to you and you wanted to be on a safer side, so you can just simply reduce the water cement ratio or use the 0.42 instead. So next will be the cement content. Let's say we begin with the 400 kg per cubic meter, and the water will be in our advanced template, it's going to be water cement ratio multiplied by total cement content, which is 0.42 by 400. It will be equivalent to 168 kg per cubic meter. Next will be the fineness modulus. You notice here that we are less than the required value, which is 2.5 to 3.2. We can check it from our guidebook as well. Here in this table, you can see 2.5 to 3.2 as fineness modulus. So now we are going to rectify this by, let's say, adding another size of fine aggregates. I have here 2 locations, so that would be perfect. We can just try 20% of our crushed sand, which is larger compared to the natural sand, and here let's say 80%, so total 100%. Let's go back here and try to check. So now the fineness modulus is 2.5 and we are complying to the requirements. Next will be the volume of coarse aggregate. Again, as suggested by the guidebook, it's 0.72. However, we can adjust it according to the compliance to these parameters below here. This is my parameter or our parameters for optimization, and for the different combined grading with regards to the application of concrete. So in this example, I'm going to choose pumpability for the purpose, and here you can see everything is complying. Like for example, the paste plus air over aggregate voids, 110% for the pumpability, but the mortar fraction by volume is 55.4. The lower limit is 55 and the maximum is 57, so it is satisfactory. For the fine sand, 25%. The lower limit is 25, and for the coarse sand, 23.3, higher than the 15% lower value. Here is the pumpability. The target line here is the red line, and our combined grading is the black line here. So it must be always higher than the red line. That will suggest that this is very pumpable. Here also, you notice I did not unclick before. You notice that the space volume or volume for slab is 29%. However, this will not be used for slab, instead column. So let me just unclick this one. So next will be the materials. Here 100% of ASTMC 150 type 2, or let's say type 1 cement in this example. Here also you can include some cementitious material if required. Next, the mixing water, 163.1. After deducting the 75% of water within this mid-range PCE. So from the original water, which is 168, now it becomes 163 because we deducted the 75% water content inside this 6.5 kg of chemical or admixture. So here are the remaining values. You can just simply watch our previous video so that you can see the calculation for this area and as well here. So moving on forward, let me just do another example. Let's say we need 13,000 psi in our specified strength. So now the challenge is how to cover the target mean strength, which is 15,000 psi. So let's say even I choose 28 days, for example. If I click on this drop down list, the available value will only be 12,000 psi. So we can double check it again from the standard. So here, going back to this table, you can see from here it's only 12,000 psi. So what we can do as per standard to exceed the value or at least equate to 15,000 psi, we can use a slag cement like or GGBS grade 120. So for grade 120, the activity index for 50% replacement is 130%, the activity index. In this example, reference to the guidebook, the 50% replacement will have 130% component index, meaning to say it is higher than the plain cement, 30% higher than the plain cement if you compare the strength. So I hope you get the point here. So going back to our table, here we have to write the 130% as the slag component index, and now we can just select again. Now you notice that it changed. Here now we have 15,600 psi because of the slag activity index or the slag component index. We apply this equation. So now the water cement ratio is 0.25 and it will have, or it will give us a 15,600 psi at 28 days. Or for 56 days it is not available since the value here is according to 28 days only. So this table here is according to a 28 days compressive strength result. So let us go back again to the water cement ratio, because I know you might get confused about 0.25 from where it came from. So let us go back to the standard. Let me show you. So here, going back again to this table, for the 3/4 inch with the high range water reducing admixture 0.25, you will notice that opposite here is 12,000 psi at 28 days. So as I told you before, it must be multiplied or increased according to the 130% slag component index. So to do that, or to verify that, let's go back to this page. So 12,000 psi, using our simple calculator, 12,000 psi multiplied to 130%, is equal to 15,600 psi, and this is why we get 15,600 psi here. So next, before we forget, let's go back to our ingredients table and just simply write here 50% of GGBS, which is grade 120 according to this table. This is the 50%. To get 130% of slag component index, we need the replacement of 50%. So this is the 50%, equivalent to 200 kg of cement and another 200 kg from GGBS. However, we are not yet finished. Here we have to follow the water cement ratio, which is the 0.25. So by just pressing this button, let's do the 0.25 here, water cement ratio. And now we have unsatisfactory value here for the mortar volume. So we just need to increase the cement, or total cementitious material, I mean. So now it's satisfactory. Another thing, we have to comply with the, or at least near to the 110%, so it will be very much pumpable. So let us increase the cement content till we get closer to 110% at least. So you can say 510 kg will be sufficient, or 520 to be exact. As well as the mixing water will be perfect for me. 130 kg is the least practical value based on our experience, since you have to replace it with ice, or sometimes when you have high moisture content for the aggregates, so that will cover the water needed for the mixing. So 130 kg will be perfect for the batching plant. However, still we need some modification here, or adjustment, since we have the insufficient amount of fine sand. So what we can do here is to visit our combination or proportion for the sand. Let us reduce this to 15% only, and here 85%. So let's go back here and check. So now we are above the 25% for the fine sand, and still our fineness modulus is 2.5 at lower value. So I believe now this is optimized. You can see here the water is too low, although we can use the, here I prefer now to use the high range. Let us use the high range PCE, due to the fact that 520 kg with 50% of GGBS, this will be a little bit sticky. So here we need high range super plasticizer, or high range PCE. So you can take a screenshot here and just try to batch in your own batching plant, and let us see if you can get the same value of average 15,600 psi at 28 days using the 0.25 water cement ratio and 50% replacement, as long as you are using grade 120 of the slag cement or GGBS. In practical application, you can also try to use silica fume. It's just that in the standard there was no any available activity index class like this, so you can try to create your own. Try to make your own data for the component index, let's say for the silica fume or the microsilica, and for the fly ash, so you can do the same thing. So that's it for today's, guys, and I hope you enjoyed this presentation, and I hope you learned something today. If you feel this video will be valuable for your colleagues or your friends, kindly share this video, or if you have any suggestion, leave your comments so that we can improve this template. Once again, thank you for watching and goodbye.